During the team's most recent design meeting, a major change had been presented, challenging the team to incorporate a more unique rider experience. This change removes the current steering controls through the handlebars and moves the input to the rider's feet, giving a true skateboard feel to the shredder. Eric's task is to assemble a new pivot mechanism, along with a connection and adjustment system to engage the left and right drive clutches. Let's see how the power of SOLIDWORKS assemblies speeds through this process and ensures the new steering control system works flawlessly. We catch up with Eric after he's already created the steering truck mechanism that allows the board to lean and the push rod assembly that controls how much power is being delivered to each track, which steers the shredder left and right. Now, Eric's job is to figure out how to translate the rotational motion of the steering truck to control the linear actuation of the push rod. He'll be making changes to the design, so he starts by reserving the assembly, since he doesn't want to step on anyone else's toes in the process. In a previous project, Eric used a tie rod assembly for a similar mechanism, so he does a quick search in DTV's cloud library on the 3DEXPERIENCE platform. He can see that there's a few sizes to choose from, so he'll go with the 170mm tie rod for now. Next, he searches for a spherical hinged tie rod end in the library as well. He needs one of those on each end, so he makes a quick copy. Now to assemble the rod end to the steering truck. By clicking two circular edges, the QuickMates toolbar gives him mate options that are dynamically tailored to what he's just selected. By making the adjustment wheel transparent, he can now click the cylindrical face of the rod end stud and an interface of the curved adjustment slot. SOLIDWORKS QuickMates presents him with the slot mate option, which will constrain the stud to only be able to move within the limits of the slot. For the next pair of mates, he knows that he'll need to have access to a few small internal faces of the rod end to mate it to the tie rod. By using Component Preview, he can rotate the rod independently in its own window, while the rest of the assembly stays put in another window. The coincident and concentric mates are done in a snap, without having to move and rotate the assembly around, searching for the right faces or edges to click. Moving on to the lower rod end, he mates the stud to the push rod assembly and then notices that the 170mm tie rod is just too short for this application. He changes the configuration on the fly and uses Component Preview on the lower tie rod end to finish mating the tie rod assembly in place. Testing the mechanism, Eric can see it's working just as he had hoped, but knows that it'll need to be tuned to ensure proper function. He adds a limit angle mate to the steering truck, giving it plus and minus 15 degrees of rotation. At the center position, the end of the push rod will need to be right between the left and right drive clutches, giving equal power to both tracks, making the shredder go straight. Eric had previously created a plane called neutral, which identifies this center position. By zooming in on the end of the push rod, he sees that it's too long, so he uses the measure tool to measure the distance from the end of the push rod to the desired neutral position. It appears that the push rod is 4.25mm too long. Eric creates a sensor so he can save that measurement and access it at any time in the future as the design changes. He quickly changes the overall length of the push rod by adding a simple math equation to the dimension field, ensuring the length will be perfect. Eric had also created two additional planes, 1.25mm on either side of the neutral plane, which correspond to a hard left and hard right turn. He opens the sensor he just created and moves the push rod through the entire range of motion. Eric can see that the end of the push rod comfortably hits the turning limits and is beyond the 1.25mm specification. Without building and testing a single prototype, Eric developed a mechanism that'll control steering by simply leaning on the board. Finished with the steering mechanism, Eric unreserves the assembly and saves his changes to the cloud. By reusing parts in DTV's shared cloud library, quickly mating everything into place, and virtually testing its function, he was able to tackle this tough challenge with ease. The steering system is working great, but Eric still has work to do. His next mission is adding comfort and control to the rider's experience by tuning a bushing that'll add proper resistance when the rider turns the board. Stay tuned as Eric uses design validation to virtually test the steering bushing and maximize the rider's control of the vehicle.